Good morning, everyone. Welcome to this week's sessions of live streams. I'm Stuart. Good morning, everyone. Good morning. Oh, right, welcome to this week's sessions of live streams. Okay. I'm Stuart. Good morning, everyone. Oh, right. Welcome to... Good morning, everyone. That was a bit embarrassing. I think we got off to a poor start there. I had several microphones set up here. Okay, so good morning, everyone. That was a bit embarrassing. I think we got off to a poor start there. I had several microphones set up here. Okay, so good morning, everyone. That was a bit embarrassing. I think we got off to a poor start there. I had several microphones set up here. Okay, so good morning. Okay, guys, I don't know if this is going to work. Sorry about this. As I say, I think I had several microphones on. Okay, Michael, can you hear us okay out there? Just give us a thumbs up when everything's okay. We've got a little bit of a delay here, so about 30 seconds, so I can't tell. Okay. So, okay, good. Okay, so yeah, it seems like I had several microphones open when we started there, so we're getting the echo. Good. Right, okay, so welcome back to all of you, and thanks for being patient on that one. And good to see the usual guys out there, and I hope you had a good weekend. So, what have we got lined up for you today? My name, by the way, is Stuart, just in case you haven't met me before. Okay, I'm the ExamSolutions guy. The guy's done all the videos generally on ExamSolutions.net. I have Michael in the live chat now from Air Maths Tuition, who's helping out as usual. So he will answer all your questions, okay, as you put them up, and it just gives me the opportunity to do the stream. Okay, so we're going to be doing angles, if you hadn't guessed already, and it's crossing the boundaries between GCSE, AS and A-level. It's very hard actually when you're doing these live streams to design something that's going to cater for everyone. So I'd like to think that this particular session should be a good one. And I will also say that there's a challenge question at the end. Okay, so if you do decide to stop on halfway through on this video, then there is a challenge question. You might want to come back, try it, and put your answer up in the description, okay, below the video. You'll only be able to do that after this is live stream is finished, okay, and it will take you a little while to do, but it's a challenge question that covers everything that we have done in this live stream, okay, and it'll be good to see who's the first one to come up with the right answer, and that winner, so to speak, will be announced on Wednesday's live stream, okay, and I will show you the solution. Okay, so do have a go at it. I would encourage you to have a go at that. Okay, so very exciting, eh? Good. Right, okay, let's get on with today's live stream. Okay, now it's all about angles, as I said. So just going to have a look at this. There'll be problems, a lot of stuff to do today. Okay, so right, okay, what we got here. Okay, let's just move it over. Okay, and set up the screen. Okay, so hope you guys can all see that. So we've got some angles here, typical angles. Okay, we got 120 degrees here, 90 degrees here, and 15 degrees here. Okay, so that's all well and good. We use degrees at GCSE level, but now we're going to have a new angle, which some of you guys might well have seen in the past. Okay, let's just put these up. Okay, these angles here, we're going to be looking at radians now. Okay, it's another kind of angular measurement, and my question to you is, which of these angles looks like 1 radian? Is it A, B, C, or D? So have a quick go. Okay, have a quick go. Just type in what you think. It'll be good to just have some replies back here. Is it A, B, C, or D, which is none of them? Okay, which one of these angles looks like 1 radian? So just type in your answer, and it'll give us a fair understanding of how you guys think about radians. Okay. Okay, we've got some of you coming in with B, others coming in with D. Remember, there is a bit of a time delay here, about 30 seconds before I actually see. Okay, all right, okay. So where is D? Where is D? Well, the answer is D, actually. It's none of them. So that's giving me an indication anyway that some of you guys most probably know what a radian looks like. I know when I used to tutor and I used to say to students, draw me a radian, they often had no idea. Okay, well, okay, here we go. It is D. What I want you to do is try and draw what you think is 1 radian. Just, here's the start line, okay, and draw another line at an angle, out here, up here, out here. What do you think is a radian? Okay, if you can do it on a fairly transparent bit of paper, that would be quite cool. Okay, so just draw a line, guess what you think a radian looks like, because I'm going to ask you to hold it up to the screen and see how accurate you are at guessing. Okay, so give you just a few moments, just say done when you're done there, that you've drawn what you think a radian looks like. Okay, just wait for a few dones to come in, and going to get you to hold the paper up to the computer screen. Just see how accurate you are at estimating what you think a radian looks like. Okay. Anybody else? Had a go at just drawing another line on here, estimating where you think a radian would be. Is it up here? Is it down here? Out there? Okay. Another straight line from this edge here. Okay. Right. Okay. We've got a few people coming in with done now. Okay. So if you do this, okay, your second line should look like that. If you hold your piece of paper up to the screen that you're looking at, okay, your angle should look something like this. Okay. So I'd like to think that some of you guys out there have done it right. I can see that several of you, and I didn't say at the time, but put up 57 odd degrees, okay, as being what a radian is. We'll come to that point later, okay. Okay, good. Right, so what notation do we use for 1 radian? You may see C. We use a little circle for degrees, as you know, but really for radians we should use a C, or you might write the word radians in. But sometimes you'll find that nothing is written, And when nothing is written, the angle is taken to be in radians. Okay? So, just a point worth mentioning there. So, let's just now move on, and we're going to very quickly just remind those people out there about what a radian is. Okay? If you're a GCSE student just coming up to think about maybe doing A-level, AS A-level, just run through this very quickly. If we have a circle, radius r, okay, and we take an arc of length r, okay, from here all the way around here, same length then as the radius there, and then join back to the center of the circle, then what we have here, this angle in here, it's called the angle that's subtended at the center of the circle by this arc. And by definition, that angle is 1 radian. Okay? So, that's what a radian looks like. It doesn't matter what the radius of the circle is, the arc length would be a lot bigger, but you'd still subtend the same angle. And my question to you is, okay, how many radians are there in one complete turn of 360 degrees? How many radians do you think there are in one complete turn of 360 degrees? Now, some of you guys might well know the answer. Okay, do type it in. Okay, do type it in. I will show you how it's derived very quickly, just in case you don't know. Good. Okay, lovely. It is 2 pi. Okay, 2 pi radians. Very quickly, I'll show you how to do it. Well done. Okay, for putting that in. We'll get to some more involved calculations in a moment. The number of radians in one turn, okay, is going to be how many times you can fit this arc length r into the circumference. Okay, and we know that the circumference, okay, is 2 pi r, and we're going to divide it by the radius r, and those r's cancel, and you end up with 2 pi, as I can see that many of you have put there. It's not 2 radians, but 2 pi. Now you know that pi is just a little bit more than 3, so roughly then it's going to be approximately 6. Can you imagine 6 of these sections? These, by the way, are called sectors. 6 of these sectors would fit round here. Not 6 exactly, but 6 and a bit. If you do 2 times pi, you're going to get 6 and a little bit more. Okay? So 2 pi is what it is exactly. Right, now, I did notice that some of you guys had put this next answer up earlier on. Okay? How many degrees in 1 radian? Okay, how would you calculate how many degrees in 1 radian? Just tell us what your answer is to 2 significant figures. Okay, I know some of you did this earlier on. I saw it come through. Just have one more go. Okay, tell us how many degrees to 2 significant figures, okay, are there in 1 radian. Okay, how many degrees in 1 radian? Go for it. Okay. Okay, Marcus coming in with 57. What about anybody else? 57 degrees. Does anybody else agree with that one? 360 divided by 2 pi from James would give us possibly the answer. Humour with 57. Fet 1 with 57.30. Remember, we are trying to get this though to 2 significant figures. That was the question. Okay, good. It is 57. And for those of you out there who unsure how we get that, okay, what we've got to do, okay, is do this sum here. Okay, the number of degrees in 1 radian must be 360 degrees, and we've got to split it up by dividing by 2 pi. Okay, it's almost 60 degrees, because there's roughly 6 of these sections in 1 complete turn. So 360 divided by the 6 here would give us 60 degrees. But if we want to be more accurate, then it's 360 divided by 2 pi. And it comes out at this value here, which is 57 degrees to 2 significant figures. Okay? So, well done. Right. moving on swiftly. Okay, I hope you guys have all got that. Okay, just in case this is new to you. Right, we're now going to look at just segments and sectors. If you haven't guessed already, we're going to be working out some questions on these. And just briefly to remind you, we have a sector here, as we had in the previous slide. Okay, and this section where you take a chord and you go from one side of the circle to the other, okay, gives us this segment. All right, okay, so let's just carry on with this. So if we are taking a sector of a circle, okay, and the angle subtended here by this arc of length L is theta. Now theta could be in degrees or radians, okay. If you're a GCSE person, you would have done degrees, okay. And you should already be familiar with how we work out the length of an arc and the area of a sector. I'd like to think that you think of it like this, that the arc length is a fraction, a part of the circumference, okay? So this arc length is a fraction of the circumference. It's a part of the circumference, okay? And that fraction depends on comparing this angle, okay, theta, to whatever we're working with, whatever we're working with, if it's degrees or if it's radians. So if it was degrees, I'd like to think that that length of the arc here would be that fraction, theta over 360, theta compared to 360 degrees, of, which is to times, the circumference, 2 pi r, okay? But when it comes to radians, your formula will be this one. L will be theta compared with 2 pi radians, because we said 2 pi was the equivalent of one complete turn, the equivalent of 360 degrees. And we would times it by the circumference. Now, if you've done this work before, many of you would know that the 2 pi's cancel out, and we end up with this formula that L equals theta r. Okay, but theta must be in radians for you to apply that formula. Okay, right, just quickly, we're going to move on and we're going to look at the area of the sector. Okay, this area in here, as I've shown here. Okay, and that's going to be, again, very similar idea, a fraction, but this time of the area of the circle. So if you're working in degrees, you would be using this formula, that fraction, theta compared with 360 of the area of a complete circle times pi r squared. Notice nothing really cancels nicely in this, okay, as opposed to this question here, okay, that equation there. When we're working in radians, however, though, this is where it turns out quite nicely. The area of the sector will be theta compared with 2 pi of pi r squared. And notice this time the pi's cancel. And when the pi's cancel, we end up with theta over 2 times the radius squared. Some of you might even know this as a half theta r squared, okay? So, or r squared theta over 2. Obviously it doesn't matter. Now, got a question for you, okay? A couple of questions here, quick ones, okay? Just to get you used to this idea, especially if you're a GCSE student, okay? Here we go. I've got this sector here, okay? And you can see there's no angle here at the moment. Just type in, by the way, what you estimate that angle to be, okay? Be just interesting. Just quickly enter how many radians you estimate that to be. Be just interesting to see what response we get. Okay, just a few moments. Let's go for it. Okay, see if you remembered what that 1 radian would look like. How many radians do you think this is? Colin comes in straight away with 2. Anybody else? Maybe it's 3. Maybe it's 4. Kaz with 2 radians, I believe. Finn with 2. Good stuff. Okay, so you got that idea then that what a radian is. Yes, it is 2 radians. Okay, so my question to you, if you've not guessed already, is I want to know what that length of the arc is. Very easy. If you work in radians, you should be able to get it instantly. Okay, go for it. The length of that arc there. Because we've got drawing, not exactly drawn to scale, you should be able to look at that and get a feel for whether your answer is going to be correct. Okay, so let's go for that one. Okay, right. Remember, it would be good to have the units in, by the way, guys. Okay. Didn't I notice has put 8 radians. Remember, you've got a length here. You can't have a length measured in radians. Okay. Yeah, good. Dead easy. It is 8, but it would be good to have the units in. It would give us an idea of what that length was. It is 8 centimeters, obviously. Okay. Looking at that diagram, getting a feel for the sense of proportion here, okay, you should be able to see that that looks about 8. Okay, let's just show you how it's done again. You'll notice I've used the full formula here, this one here. Okay, I always tend to do that when teaching. Okay, but the 2 pi's cancel. Okay, gives us the angle of 2 radians times the radius of 4, coming out at 8. Okay, 8 centimeters. All right. Okay. Right. Again, if you haven't guessed it already, what's the area of this sector? Yes. What is the area? Okay. Give us the area. And again, you'll notice that working in radians is a lot easier than working in degrees. There's no need to convert radians to degrees. Okay. So just go for it. What is the area? So we're looking for that area. Good. Good to see you putting those units in as well. 16 centimeter squares. Excellent stuff. Okay. Again, just quickly show you. Okay. The area is the angle 2 over 2 pi of to times the area of the circle, pi r squared. The pi's cancel though, and you will end up, and the 2's cancel as well, okay, in this example, so you end up with 16 centimeter squares. Excellent. Okay, now I thought I'd just slip this next one in. Okay, I think you need to think a little bit more. Okay, I've got an algebraic question for you, and so in this one, okay, find the area A, area of this sector, in terms of L and R. Okay, so give you a clue, there's no angle written here. You're going to have to find that first. Okay, so go for it. Okay, give you, I would say, maybe a minute on this one. It'd be good if anyone can come in quickly with the answer before that minute is up. Okay, I'm starting the timer off now. Go for it. Okay, nice little algebraic one. Right. Okay, we have Huma coming in with, I believe that might be 1R. No, it can't be 1R, surely. It might be LR. What about others? Okay. Half R from Natalie times L. This is interesting. Din with RL over 2. Huma with 0.5R. Okay. We have a change there, 0.5R. Remember, there was a clue here to give your answer in terms of L and R. Okay, so Kaz, L over, I believe, 2 squared maybe there. Okay. Erica, LR over 2. So who's correct? We've got quite a few differing answers here. Okay. Let's just, we've gone over the minute. Okay, so we've got a half LR. Okay, let's go and see what the answer is. But well done for all of you for taking part, whether you got it right or wrong. I've said let this angle here theta be theta, okay? We need to find that angle theta, and we turn to the formula that the arc length L is equal to theta r when you're in radians. So if we make theta the subject, theta is going to equal L over R. Okay? Now, when we go back to the area of the sector, the area, okay, let's just bring it up. The area we know is theta over 2, or half theta r squared from down here. Okay, so I've just got to substitute theta in here. So if you substitute for theta, you're going to get the theta, L over r, and the 2 down there, times r squared. The r's cancel, okay, and what you end up with is LR over 2, or 0.5 LR, half LR. So I can see there's a few of you guys out there giving us that answer. Well, not a few, actually, well done. I can see quite a lot of people up there giving us that answer. Great. Okay, thank you for doing that one. Okay, so we're going to move on to almost the final slide, and then it'll be the challenge question on the last slide. But here we go. Okay, so we've got this question up here. We're going to have lots of short questions just so that you can quickfire. Okay, quickfire questions. The first question up, we've got this sector here. Okay, and you can see that the subtended up here is 2.4 radians, got a radius of 5 centimeters, and your first question is to find the length of AB. Find the length of AB and give us your answer, okay, to let's say 1 decimal place. Okay, 1 decimal place. And by the way, you're going to need to use your calculator most probably, and you need to know how to set it up in radians mode. So I'm just going to bring the calculator up if you're unsure of that. Some of you guys will carry on working, I'm sure. Okay, so let's just bring that calculator up onto the screen. If you've got a Casio Class Whiz, for instance, okay, and you want to put it into radians, what you just need to do is just go Shift, menu setup, okay, and there we go. Okay, look at option 2 here, angle unit. It's number 2. Press number 2, and we've got the option of degrees, radians, or gradient. Okay, or gradient. We want radians. Okay, so you switch to mode 2, and you're into the calculator for radians mode. Okay, so I'm going to just take that calculator off. How do you get the length of AB? Okay. For any other calculators, you're going to have to use the menu button, I'm sure, to find out what where the radians mode is. Okay, so do explore that. Okay, so we've got some answers coming through here. We're going to go for 2 significant figures, or 1 decimal place. Okay, I noticed Din's come in with an answer, and Kieran's come in with an answer. Isabel now with an answer. Good to see those units, by the way, on there. If you're unsure of how to do this, then you're going to need the cosine rule. Okay, so that's the quickest way of doing it. You could draw a right angle down through here and use normal trigonometry, cut the angle in half, work out half this length, and then double it. Up to you. Okay, so I'm going to race on. I'm sorry guys, but we've got quite a lot of little bits to cover here. Okay, so if you're using the cosine rule here, our A side would be this side, okay, this time. The cosine rule says if you want to find a side, you square it, okay, it's equal to the sum of the squares of the other 2 sides minus twice the product of the 2 sides times the cosine of the opposite angle to the side you're finding. So using the cosine rule here, okay, we've got AB squared equals the sum of these 2 sides squared, 5 squared plus 5 squared, minus twice the product of those 2 sides times the cosine of the angle opposite the side you're finding. So, okay, cosine of 2.4. So you need to have your calculator in radians mode to do this. Okay, and if you do that calculation, right, you should end up square rooting 86.869 and so on. And you'll find you get 9.3 centimeters if you give it to 1 decimal place, or the equivalent of 2 significant figures. So well done for getting that one. Okay, right, okay, next question up. You might be working ahead on this, I don't know. Okay, the next question is to find the area of the triangle, AOB. These are all kind of common questions that you get with this type of work where we're dealing with sectors, segments, okay, areas of triangles, all of this stuff is used, okay, in questions like this. And this will be used in the challenge question, just giving you a few hints there. Good, okay, Kieran coming in with 8.4 centimeter squares. Okay, so I've just seen that I've got the calculator up on covering the screen. Okay, so we'll take that off. Okay, so how are we doing? Okay, good to see some responses there. We're going to go for the answer to 1 decimal place or 2 significant figures again. Okay, good. 8.4 centimeter squares, and I see you're using the best formula out there for something like that, and that is the area of a triangle. You should know, if you're a GCSE student, that if you've got 2 sides to a triangle, you're given them, and the included angle, which I've called C here, the area of the triangle will be half AB times the sine of angle C. And yes, the answer is 8.4 centimeter squares. So great to see some good response there. Here's the calculation. Okay, the area is going to be half times 5 times 5 times the sine of 2.4. Again, make sure you've got your calculator in radians mode. And if you work that sum out, you end up with 8.4 centimeter squares to 1 decimal place. Okay? Right, so what I'm going to do next is we'll just remove those formulas there. Okay, the area of the triangle and the cosine rule. And you should have more space to do the next question here. And that is to find the length of this arc, ACB. Okay, we're back to finding the length of an arc. So you haven't got the formulas in front of you. Hopefully you've remembered them. Okay, so going for the length of that arc. What will it be? Okay, give your answer, okay, to 1 decimal place or whatever, or is it going to be exact? Okay, this is the beauty often with working with radians. Okay, good. Okay, good to see some of you guys still out there working away. All right, the answer is, in fact, 12 centimeters. Well done. I see Isabel came in first there with that one. Well done. And Humour and Din followed on, and Colin afterwards, and so on. Okay, well done for taking part. Yes, it is 12 centimeters. Good to see those units. Again, just a quick reminder, the arc ACB is the angle, 2.4, compared with the number of radians in a complete turn of 360 degrees, that's 2 pi, and then it's of the circumference, 2 pi r. So if ever you forget the formula, okay, go back to basics. All right, we know that those 2 pi's cancel. You could have done 2 pi times the 2.4, the angle times the radius when you're working in radians. It gives you 12 centimeters. Okay, easily done. Right, next question. Okay, find the perimeter now of the segment. Quite a common question. Find the perimeter of the segment. And with this, okay, give me that perimeter. We'll go for 1 decimal place. Okay, 1 decimal place is the answer for the perimeter of that segment. Okay. Okay, you're coming in with answers, but 1 decimal place would be good. Okay, just check it out. 1 decimal place. Interesting answers here. Okay, remember it does say perimeter of the segment. Think about that, the perimeter of the segment. So I hope you guys know or remember what a segment is. Okay. Right. Anybody else? Okay. Lots of answers coming in. Okay. And I see we have a right answer, and it has to go to Natalie. Well done, Natalie. Okay. Kieran coming in. It is 21.3 to 1 decimal place. So let's just check that one out. Okay, the perimeter of the segment. Remember, the segment is this shape here, going AB and round the arc length here, C. It's across here and round here. Remember, this area here is our segment, okay, in here. Right, so all you have to do is take your arc 12 and add it to the length AB. Notice I've used the unrounded version here, just in case we had to round up later on. But we get 21.320 and so on, which is 21.3 centimeters to 1 decimal place. Okay, so well done. Okay, for not being tripped up there. It was the perimeter of the segment. So if it was an exam question, be careful. Okay, we got one more before the challenge question appears. Okay, no, we haven't. We've got two more little questions. Okay, beg your pardon. Okay, this time, area of the sector. Okay, OACB. The area of the sector, OACB. So, let's go for that one. Nice, quick, easy one. Again, working with radians makes it so quick and easy. The area of the sector. Okay, Huma has come in with an answer. Din's come in with an answer. Good to see these answers. Okay, Isabel. Kieran. Okay, you're all storming in again. Okay. Right. Let's see what the answer is. Well, I'm going to say the answer is in fact 30 centimeter squares. So well done. Okay. I noticed some of you got 30.0, which is interesting. Really, it's 30. The 0.0 is suggesting that there are other decimal places behind that. It's 30 exactly. Look, okay. The area is the angle, 2.4 over 2 pi. Okay, that's the fraction of the area of the circle. Again, I'm giving you the full formula here, just in case you forget it. The pi's cancel. Okay. And what you end up with is an exact value. I suspect many of you, maybe when you put 30.0, might have typed in pi in your calculators. I'm not sure about that. But those irrational numbers, the pi's, cancel, and you're left with an exact value, 30 centimeter squares. Okay? So well done to all of you out there. We got one more then, okay, before the challenge question. The area of the segment now, ACB. Okay? The area of the segment, ACB. Okay. Yeah, I'll try and give you as many tips as I can on the way. Okay, I see I've just read Huma's tip there. If I can think of any other tips, it'll be I'll chip them in. Okay. Yeah, who's the quickest? Din now has come in with 21.6 centimeter squares. We're giving this one to 1 decimal place. Does anybody else agree? Okay, keep you on your toes here. Okay, 21.6 centimeter squares. We've got 2 people on it. 3, I see. Din, Amy, Natalie. Okay. Anybody else? Okay. Yeah, it is. You've all guessed it, right? Okay. Well, I hope you haven't guessed it right. Okay. You've worked it out, I hope. 21.6. It is indeed. Let's just show you again. The area of the segment is going to be the area of the sector minus the area of the triangle AOB. Okay, so the area of the segment, this area in here, is going to be the area of the whole sector minus the area of the triangle. So all you've got to do is call back those answers, and we have the area of the sector, which we found as 30, take away the area of the triangle, which we had as 8.443 and so on. Okay, the unrounded version there, okay, gives us 21.557 and so on, which equals 21.6 centimeter squares to 1 decimal place. Okay, so again, I can see Humour saying couldn't remember the area of the sector formula, and this is my point, that yeah, just go back to basics. It's a fraction of the area of a complete circle, as I use up here. If you forget, okay, it's the easiest thing to remember. And remember, arc length, fraction of the circumference of a complete circle. So you can apply it then in degrees mode or radians. Okay, right, okay, so let us just take you now to the challenge question. All right, now it's coming up here, and we have this question, and here's the diagram. I'll just explain very quickly that OBCD is a sector, okay, of the circle here of radius 6 centimeters. You can see the arc length around here is 15 centimeters, and I've got these two other sides to this triangle ABD, if you like. We've got the 10 centimeters here and the 7 centimeters here, and your job is to calculate the area of this shape, okay, giving your answer to 1 decimal place. And what I want you to do is to put your answer in the description below the video. All right, and I will announce the winner, the first person, when I do a live stream on Wednesday. Okay, I'm going to be very strict about this. Okay, I'm giving you a few clues in the question. Okay, calculate the area of ABCD, giving your answer to 1 decimal place. So do put your answers in the description. It'd be good to see how many people take part. Okay, now I'm going to come off the screen now. Okay, just come back. You can play the video back when this live stream's finished, and you can go directly to that last question. So I'm just going to come back on. Okay, so hopefully you'll take part in that. And it's great to see how many of you took part as well. I hope you got something out of that, whether you're a GCSE student, just revising, say, your AS A-level maths, just helps keep the brain going. Okay, so yeah, all it leaves me to say is thank you very much to Michael for helping out on the live chat as usual when I'm on. Michael's on, by the way, tomorrow doing I believe a GCSE live stream. You can find the links to that on my YouTube channel, ExamSolutions.net YouTube channel, or go to the links in the description. Okay, you'll see links there, I believe. Okay, so yeah, see you tomorrow. Okay, I'll be doing the live chat then, and Michael will be live streaming to you. Have a good day, and I will see you on Wednesday. Okay, bye.